Start by measuring total circuit volt or resistance before we even turn on the circuit. So to get total circuit resistance, you've got to have it's isolated from your power supply here. And I've isolated on the ground side and the power side. And now I'm going to turn on the switch and we'll get total circuit resistance, which is 6.2 ohms. To get each component, get the individual components' resistances, we have to break up the circuit and isolate it from the individual components. So here we're getting the resistance of the switch and the fuse, 0.8 ohms. For C, for component resistance, we're getting 4.9 ohms. And then for bulb B, it's about 0.7 ohms. All right? Now I'm going to hook everything back up in series. We're going to turn on our circuit and then we'll measure our voltage drops. So turn on our circuit. I'm going to switch my meter to volts DC. So total circuit voltage you can get at your supply, 13.79. And then we will take it at each individual component. This had very low resistance, so it's going to have a very low voltage drop. So we've got like 73 millivolts. On C, we have 13.56. That had the highest resistance, so it's going to have the highest voltage drop. Bulb B is 148 millivolts. The reason why bulb B is not lighting is because bulb C has such high resistance. It's got the largest voltage drop, and that doesn't leave enough voltage to power bulb B. So I'm going to turn my meter off. I'm going to turn my circuit off at the switch here, and I'm going to break my circuit to measure amps. In series circuit, your total current and your individual components are all going to have the same amount of current because current remains the same. So we're going to switch to amps DC, swap our lead, and wherever we break the circuit at, we're putting our meter into the flow, and we're going to put our meter leads where we broke the circuit at. So now power will come through the fuse, through the switch, go through our positive lead, go through the meter, come out through the black lead, and start its travel to bulb C, then bulb B, and back to ground. All right, I'm going to turn on the circuit. The light bulb should light. Light bulbs light. I have 0.255 amps or 255 milliamps. If I measure anywhere else, it's going to be the same. So I will break it over here after bulb B and show that it's about 255 milliamps. I had the lead swap, that's why the negative's there. 255 milliamps. All right? Amperage remains the same, so you only need to take one measurement. So that's everything on a series circuit.